All right. Some of you have already participated in some of the sessions. Um, we have spoken about particulate matter, carbon dioxide, carbon monoxide, ozone, formaldehyde, and today we have the sessions for nitrogen and radon. So let me jump to radon to nitrogen dioxide. Here we are. Okay. So the main question, as always, is what are we going to do with this space adaptability feature, and whether we would like to link the average times concentrations with different indoor environments. The majority of the people answered yes during the survey, but again, we didn't have a lot of participation, only 4 responses. So here is what I could find for nitrogen dioxide when it comes to some of the pollutants, some of the average, sorry. And as you can see, we have some ceiling with maximum 4 limits or guidelines present. Then we had 15-minute average times, 1, 8 hours, 24 hours, and 1 year. And 9 of the guidelines were undefined, so they didn't specify whether they have this is a ceiling or this is an average time. All of the values are in micrograms per cubic meter, and eventually I'm going to ask you during the end of the session which is the best unit to measure gases, in this case nitrogen dioxide. But before we do that, I would like to discuss with you the limits that we proposed. So basically, we have tried to find the most strict limits, and for 1 year mean, we are proposing 10 micrograms per cubic meter. For 24-hour means, we're proposing 21 micrograms per cubic meter. For 8 hours, 40, and for 1 hour mean, again, 40 micrograms per cubic meter. Again, the majority of the people agreed. Nitrogen dioxide limits are in a better state than some other pollutants that we have explored. So I would like to ask you, all of the participants today here, what do you think about those numbers? Are they good enough? And also, if we should go with a ceiling limit, one ceiling limit, instead of having those average hours. If for some reason you cannot speak, you can always write a comment on the chat.
Is it possible to bring the slide up with them again?
Yes.
Thanks. I'll speak in a second. So just to confirm, this table's what you are
What?
suggesting at the moment?
No, this table is what I
The
could
options.
find,
Yep.
yes, out there regarding standards around nitrogen dioxide and specifically indoor spaces. Some cases they are for both, like from WHO.
Yep. Did you do you have a list of where they actually came from? Obviously, we've got
Uh, I,
Minimax, and
I,
how divergent is it? One max and the rest of them are low.
yeah, I do have a list, so let me bring it up, if that helps. So let me know if you can see it. I'm gonna try to bring it on the screen. But for some reason I can't. Come on. Oh, I cannot because it's in full screen. Wait. Okay, hopefully you can see now. Yes, you can see. So those are the limits based on of the countries that
Yep.
we could find, and the date also that they were introduced, and whether they are like guidelines or non-governmental guidelines in some cases, or even regulations.
My feeling is that anywhere where it's more stringent than the WHO guideline will be hard to justify unless there's a very compelling reason. So for the 1 hour, for example, 200 is probably the tightest you could go, even though there are some examples of 40. I think that,
Right, so like for 1 hour, we are proposing the 40 micrograms, which is coming from the UK apparently. And
but for where in, I'm not sure that's true.
well, we found, I'm not 100% sure of the information. We basically used the CT34 website, where they have all the standards they are listed. So this is the website basically that we are using in order to find the standards. Also WHO, and recently we found a new one from the German government. So basically you go here and you write which pollutant you like nitrogen dioxide, and you search. And now if we try to find UK,
The one from WHO is for outdoor or indoor?
it's for both actually, it's for
Both,
indoor and
okay.
outdoor. So UK.
So the 40 is a long-term average.
40 was for, sorry, yes, 1 hour. So for them, I don't know why I have incorrect data there. I will have to check it again on my end. But in some cases they have twice the same thing. Oh, maybe it was that I've mistaken. And the document that comes from, they don't have a document. Okay, so maybe this is a mistake from my side.
Yeah, I think it will be.
Yeah, another UK. Oh, they have this one here. Let's see. And they have a document attached to this. So according to this document, for some reason they say here that they're proposing 40 micrograms per cubic meter. But again, applications for students in schools.
Okay, that's very interesting. And then, so that's which the other.
And it's something that updated in 2018.
I'm going to
No
check that.
standards, not the department. There's no core standards. Yeah, I can give you the link directly to the chat. And you
So
can...
I've got the document. I'm having a look at it now.
Okay, perfect.
Yeah, we can talk about something else for a second. Look at this.
So the WHO that's the most stringent one then, it seems? Or
No,
maybe.
it's not. I don't think it is. That's the...
Maybe, but the problem is WHO, for example, does not have 1 hour mean value.
It's one here.
1 year, I see, okay, yeah.
And just if you consider that the WHO is rising in some hours of the day and going down, if you take into account only the outdoor, the average is something like this, even if the peaks are very high, much more higher.
Yeah, so maybe nighttime it's very low, perhaps, and there's no smog or sun to cycle with those up.
Going back to that document you just saw, that 40 is definitely for 1 year, not 1 hour. So whoever's generated that website has made a mistake.
Oh, I see. So yeah, it's governmental side.
Yeah.
Again, we are asking whether we have to go with one unit in order to eliminate this issue that people confuse those average limits, right? And in some cases, we cannot find a good hour limit for the specific time frame that we are proposing. So I don't know if someone else has a comment on that.
So go ahead.
Oh, I was just going to ask, I mean, from people's experience with sensors, are they able to monitor these values? If it's the, let's say the Singapore value, if it's for 8-hour mean, or UK, if it's the 1 year mean, I guess.
Yeah, not, in general, not easy to monitor the nitrogen dioxide at the ppb level, so low concentrations, or in low-cost indoor devices.
Mm. And we're focusing on the indoor application in this case.
Right.
Yeah, the problem is if we set it too much conservative, considering also the accuracy that an indoor device can have, we may have errors to bring ceiling exceeding very, very easily. So probably 40 microgram per square meter can be a good option, considering also the accuracy of the instruments.
My view is that I like the idea of a long-term sort of threshold for a year, but also a 1 hour and an 8-hour. So I would like those 3 averaging periods that sort of pick up most exposure, and then for the 1 hour, I think it should be 200. I think for the 8-hour it should be 40, and for the annual it should be 10.
Okay. Anyone else agrees or disagrees with Kieran?
Well, I guess from not having used NO2 sensors, but trying to make an NO2 sensor, our company is working on that. I think, yeah, what Kieran said is the most reasonable. If it's something that is, I guess, something around 100 ppb. I'm trying to convert it from what I'm usually used to with ppbs, but we're aiming for 100 ppb or less for the sensor indoor use at the lower cost end. So I think something, yeah, 40 over the 1 hour mean will be a little challenging, but I think 200 for the 1 hour seems reasonable, and then 40 for 8-hour, that seems reasonable.
Mm-hmm. Kieran?
Yeah, I'm just slightly concerned if we confuse like defining these standards based on the ability to monitor. Now, I completely understand that monitoring is uncertain, and that's a key part of it. But I think if we're talking about the health effects, then we should be focusing on what the actual level is, not necessarily worrying about sensors. We can then sensors will evolve and get better over time, but we should be focusing on we have one stab at this, don't we? And so we should be trying to get based on the evidence and the health effect, which is why I think the WHO guidance is what's the 24-hour WHO guidance for this? I can't remember.
I don't remember, but let's go back and find it. So WHO 1 year is 10, WHO 1 hour is 200, and they don't have for 24 hour, right? Okay, they have something here. 25 micrograms.
So there's 25. I'm just thinking that so a 40 micrograms as an 8-hour exposure might be fairly reasonable then. because you'll have periods of high exposure to come and then low exposure, which will probably average out at about 25. So if you had 8 hours of 40, and then the rest, then it probably average down to 25 fairly easily. I'm just trying to think about the practicalities of this. Yeah, I'll stick by my thoughts that 10 for an annual, 40 for an 8 hour, and 200 for 1 hour. Because particularly with low-cost sensors, you can then focus on the spikes from the 1 hour, which
Mhm.
they should be more reliable at measuring those higher spikes, even if they can't accurately measure for an annual mean, which is much lower.
Something common that we have been discussing with the other sessions and other working groups, like for carbon dioxide, monoxide, formaldehyde, and ozone, is the fact that it's going to be easier if we have like a ceiling limit, one ceiling limit for the pollutants, rather than having all of those numbers that potentially can create confusion. And this is also some feedback that I received from some academics from the US that I spoke, from the Brown University specifically.
Is the one standard for the shorter time period or the longer?
The question now is which one we should adapt, right? Like if we go with a ceiling, we can take any of those numbers and make it like a ceiling according to what they propose.
But that's, I mean, with CO and stuff like that, there is a point where you're going to die from exposure, and there's a limit there. There's a point where very noticeable impacts on your ability to work and concentrate to happen. So, but with NO2 and other pollutants, there's not a change in effect necessarily that's quite threshold basis there. There's non-threshold impacts. So I think that, and there's also two different sides of it. There's a short-term and long-term impacts. So I think that it's a risky business for NO2 and PM to just be having a ceiling target, unless that ceiling target defaults to the lowest, most stringent one, which might then not be feasible. And if you end up making a standard that no one can achieve, it will just be ignored.
Mhm.
So I don't know. I'm not completely sold. It's a nice thing to have, but I don't think it's practical.
Right. Yes, Christos.
Yes, it's also worth mentioning that, for example, if you set it to the lowest standard and you have a gas stove in the States, you pretty much hit 7.5 micrograms right there with the use of the gas stove. So you're very close to exceeding the long term off the bat. Something that is worth
Considering, yeah.
Yes.
Thank you. Okay. Any other comments, maybe?
It's
Michael?
is it the gas stove is the main indoor pollutant for the residential, but are there any indoor sources from, like, say, at work or office if they're not using gas stoves?
Unless they have some kind of leakage from, let's say, appliances for heating and so on.
Mhm.
I
Or
don't
maybe
think.
the ventilation from the outdoor close to the street or something.
Yeah, in most cases, it's going to come from the outdoors traffic.
Okay.
Rarely can be also cars that are in garage that are bringing in residential indoor the exhausts,
Mhm.
especially if it is cars.
Mm-hmm. And so in other countries, diesel is still pretty common use?
Here in Italy, like 75% of cars are diesel, or
Okay.
60% still.
Mm.
I don't know in other countries.
Yeah, in
Very
Spain as
common
well.
already.
In Spain as well, and the number is high, and so this is the reason we have huge problem with nitrogen dioxide in cities like Madrid and Barcelona. And now they're restricting vehicles from the centers, and some of this pollution is circling around cities as cars operate around.
Mm.
Could you go back to the first slide again, please?
Yes. This one?
Yeah, thank you. That 0.96.
This is coming from Norway. But it
I-
does specify what it is, like if it is a limit or...
I'm surprised. Check the reference because I imagine that's in milligrams, not micrograms.
No, they actually give it in micrograms. At least this is how I copied. Maybe they introduced the data again incorrectly.
I think they probably have, because the 960 micrograms, or reported down as 0.96, is milligrams is used in the UK.
Yeah.
Just
Wait, let me find-
it's just too coincidental to be exactly the same.
Yeah, and they have one here for 15, and where is the other? Norway. Oh, it's here. So I just converted all the values in microgram per cubic meter, but they had it like that from the beginning, like the original value.
I reckon that's a mistake by them.
Maybe.
Yeah.
Hmm.
With such values, probably you can neither breathe. Very high values.
I do, yeah. I still maintain I think that we need some sort of long-term exposure versus short-term exposure, because obviously a spike is going to be different to just a long-term dose from lots of small contributions. So I think that they are different.
But the question is, indoors, are we going to have short spikes from nitrogen dioxide?
Any combustion, it will. So from gas stoves, if there's a gas fire in there.
Like, because we were talking about in the particulate matter working group about those short spikes of PM, especially when you cook.
Yeah.
But again, they are in a very short period of time. It's not like even half an hour, and depending what you're cooking always. But in most cases, those spikes are going to stay up for 30 minutes or so.
Yeah.
And that's the reason I'm asking if that's the same case for nitrogen dioxide.
We've got a gas boiler, and they can, if they're not well fitted,
Mm-hmm.
they can be. Yeah, as long as it's on, sort of thing. So we can get short spikes and also longer ones.
Mm-hmm.
Food burning, for food that is remaining on the stoves and is burning after carbonizing, can produce also nitrogen dioxide. But
Is there seasonal times for heating also? Just for the winter time, it's maybe spiking for the wood burning application for indoor, just for heating.
You get much NOx from wood burning or not?
No, just he's mentioning if, like, when you would burn during winter, maybe something similar happens with nitrogen dioxide for heating. During winter, concentrations are higher than during summer. I'm not sure, to be honest with you. I haven't looked into that. And again, I think it depends where you live and what kind of appliances do you have. In my house, everything is electric, so I don't have this kind of a problem. But if you rely on heating, boilers and stuff like that with even natural gas, then nitrogen dioxide is going to be a problem for you.
Mm-hmm. And then I guess the location of the garage as well. That's the other factor, perhaps the way it comes indoors from the turning or parking and things.
Well, if we take another example, when I was living in the US, inside my house, there was a separate room where the boiler with natural gas was operating. They had in place a ventilation system just for this device. But I was always concerned, like, because underneath the door there was a gap like that, you know, maybe pollution will escape. And I was always placing tape around it, around the door. And yeah, I don't know, but you know, the configuration of houses around the globe are different, are not the same. And even in the US, where they are standardized in most cases, now I was living in a condo, but if you live like in a house that is yours, who knows what you have, how the building is constructed, and you know, all of those things are in place. Like, for example, I will bring you another example. Near my house, there was a fire station, and they had the exhaust from a wood burner that they have there in the same place that they had the inlet for air.
Wow.
And every morning when I was walking to go to work, I will see, you know, the smoke exiting one place and entering the other one. And it was like crazy.
Oh my God.
Unfortunately, I've got to go for another meeting now. But do let me know of the outcome, and if you have any specific questions, do just reach out.
Okay, thank you.
Yeah.
Thank you for being here.
Thanks, everyone. Cheers.
Thanks.
Okay, in order to move a little bit forward, we had only one note during the survey, and they said that limited accuracy of all three cross-sensitivity and low-cost nitrogen dioxide sensors should be considered. Very low limits could trigger false positive notifications due to positive sensor accuracy. I don't remember who said that. Maybe it was you, Mike.
Maybe, yeah. I mean, I'm thinking it, but yeah, I don't know if I wrote it. Maybe somebody else as well.
Mm-hmm. If you would like to comment on that, or then I can move.
Yeah, so they're both oxidizing gases that our sensors are metal oxide based, and we make a very sensitive material that is able to, right now we're making ozone sensors that can go down to very low ppb, around 25 or 50 is what we're testing at, but we expect it to go much lower. And we're testing it without heating, so we expect with heating it will get much lower than where we're testing it at 50 right now. But the factor is that the materials we're making happen to be selective for certain gases, but we don't expect them always to be selective for particular gases, just from kind of the luck of making a material that happens to be selective. So we expect that the best way to address this issue of being sensitive to both of these similar oxidizing gases is from the filter packaging of the sensor. So if we make it a very sensitive material that can go at this very low ppb level for one or the other, then the packaging from the material base point of view, we can absorb selectively one or the other of these gases and then make a sensor that can work for one or the other. So, but we start with a very sensitive material and then work backwards from there and see if we can package it appropriately to remove the other cross-interferent one. And there are materials that selectively absorb one versus the other, but they're just not good as sensing materials. They're just more the kind of selective absorption. So that's our approach. But I had mentioned to Christos that for NO2, the way we're tackling that is we have materials that we're investigating, but we're applying those material that work towards a DOE SBIR grant that we applied for, that we'll find out in the summer if we can get the phase 1 proposal started.
Okay. And now the question for $1 million is, which unit of measurement are we going to use for nitrogen dioxide? WHO is using micrograms per cubic meter, and some other countries. Of course, we're talking again about a gas, and it makes sense to measure it like in parts per million or billion. Any thoughts from your sides?
If possible, both. I think maybe just side by side. If I understand researchers are more familiar with perhaps microgram per meter cubed than WHO, but from our point of view, all our instrumentation is in the ppb value, and we tend to report those. So we just have to convert every time, but perhaps it would be useful.
And let me ask you something, because of a conversation that we had yesterday, for example, we propose going with parts per million or billion, and then inside the standard mentioning that for the accuracy, you have to make a conversion based on the temperature and atmospheric pressure at the moment you took the measurement. So you have to carry this information, if you like metadata, in order to do the conversion afterwards. Is this something that you do as a company, or you rely on a basic 25 Celsius, 1 atmospheric pressure standardized conversion factor?
For us, for now in our lab, we just rely on the basic, we assume 25C and 1 ATM, but I could see where being more precise with the right instrumentation, it would fluctuate slightly, and that would be useful. But perhaps simplicity, we can assume it's normally indoor room temperature, not too uncomfortable or not too different on the pressure, perhaps.
In general, when we talk about indoor environments, the temperature aspect is more stable. It's never going to be 0 or minus degrees. And it ranges between, let's say, 18 degrees Celsius, I'm talking, and maximum like 26 during summer, maybe. So maybe we can propose something like that, like you take measurements and you display them in parts per million, parts per billion. But then if you need like this absolute number, then you should rely on the temperature and pressure during the measurements. But then if just for communication purposes, you would like to communicate the values in micrograms per cubic meter, you can use the standardized version of 25 1 atmosphere.
Yeah, I think that's reasonable. I mean, I know there's some extreme cases, but hopefully in those environments, they have a way to kind of keep the temperature at a comfortable range, perhaps.
I mean, our standard is aiming residential, hospitality, and buildings that they are outside of the scope of occupational health, right? So all of the time temperatures are going to be in reasonable ranges, and not very extreme. All right. Unless someone wants to add something else, I will take into consideration what Kieran said about his proposed values. As I see, he sees values and have all of those different average limits rather than have a ceiling. And I will try to come up with numbers that make more sense. I will also reach out to some more academics that we have in our groups, because I would like to hear their opinion from their experience in the scientific field, and come back with another survey to determine the actual numbers that we are going to implement. Yes, please, Kiro.
I was just trying to make an example of conversation. If we move 100 ppb of NO2 to micrograms per meter cube at 15 degree, it will be 178. At 35 degree, will be 166. So more or less 10 micrograms difference. So not so much in general. So probably this can be explained if we want to say we are simplifying, because at the end, not so much difference if you are analyzing it from temperature that can vary from 10 degree.
I understand you, but believe me, in some cases, people are very opinionated when it comes to a number. So if absolute measurement is important, it's crucial to use those temperature and atmospheric pressure values in order to do the conversion, even if we are talking about minus plus 10 micrograms per cubic meter.
No, I don't want to say that we have to skip. Okay. You have to make the conversion using the right temperature. But if you want to simplify using the standard temperature and humidity, you are making an error that is roughly 5%, for example. So if people want to convert using standard temperature and pressure, they know which errors they are committing. Because of
Okay.
course, if you want to be precise, you don't want to make any errors. But if someone want to simplify, you want also to know which error is committing. So
Mhm.
probably showing an example can give idea if you can do it or not in your case.
I think we will give examples because we
Yeah.
have to compare them with what WHO, let's say,
Yeah.
gives out, right? So yes. And Azhar, I see you raised your hand earlier.
Yeah, I just like to comment on this duration, the periods. It mostly depends upon the exposure when we talk about and setting the standards or the
Mhm.
guidelines for short term, like 1 hour. That could be for a healthcare setup where we have more vulnerable population, and 1 hour could be have more health impacts.
Mhm.
But if you look on to the kind of a settings like educational institutes where the kids are studying the 8 hours, or in offices where we are working, is 8 hours standard is the most one. But if you look on to the residential purpose, then I think 24-hour is quite reasonable, considering the technological limitations, because if we go for like an hour, 1 year average, still I think the sensor technology is underdeveloped for that long run. So, but anyways, 1 hour, 8 hour, and 24-hour, they are considering to be a reasonable time limits where we
Mhm.
can think of whatever the values we are considering. And other thing is about the units. I think the PPB is very reasonable, as other folks talk about, and there is not much difference when we talk about the indoor where we are using some, whether we are using natural ventilation or HVAC system. We always go for a temperature and humidity where we feel a thermal comfort. So the PPB is a reasonable uh, unit to communicate and easy. And then we have some notes for whoever is interested, whether it's a compliance purpose or for a research purpose, that they can convert using the standard formulas. That's it.
Thank you so much. So I would like again to thank. Oh, Christos, please.
Yes, maybe really quick one point, like maybe to address what the previous person that left maybe was trying to
Kieran, yes.
say. While there is no death, right? Or what is the end point of concern? NO2 has a lot of linkage to asthma.
Mhm.
So asthma attacks, you're going to be having them especially in schools, at lower thresholds. So if we want to consider something like that, I think a more stringent threshold, right? Would be useful. So
You mean like a ceiling number?
yes.
Okay. Indeed, cases for asthma are rising lately, and recently I read another paper around it in schools. And I mean, yeah, GoQS needs to be around health, how we can protect occupants, right, from a variety of health outcomes. And in a previous sessions that I had about carbon monoxide, someone was saying, why are you only stating about the health outcomes from carbon monoxide instead of the death that they can be count? And I was like, because, okay, we know that carbon dioxide can kill you instantly, but also we have to consider all of those health effects. Personally, I don't like to live a life where I will be sick and I will have to rely on medication. I prefer dying instantly rather than having all of those troubles in life and struggles and doctor visits and all of those things that no one likes. And apparently, in some places of the world, are really expensive, or even not an option because they don't have the means to deal with those issues.
Did we decide perhaps what the 1 hour mean might be for? I know Kieran had suggested 200.
Um, yeah, let's go a little bit back and see the whole here. So all of those numbers are proposed like 1 hour, right? Like all of those here. And in most cases, they begin from 40, sorry, here from the United Kingdom, and they can go around 200. 200 is like the standard, it's commonly seen, is the
Mhm.
more predominant number. But I mean, like 100, it sounds more reasonable to me than 200, to be honest with you. And in
Mhm.
some places, they have like 2 tiers, 100 and 200 for NO2.
Mhm. Yeah. What's the rest of the group's thinking for if we do something in line with what health advisory recommends, maybe if it's based on short bursts, 1 hour, is 100 a more reasonable number?
You?
Yeah, I think I agree. I think some that in the health should give a much more deep insight on this. But in general, one question: the ceiling is the one that will be used to calculate the index, the weighted index.
So the index is going to be developed after we figure out the numbers for the general purpose protection, right? So then I will ask, which ranges do you think they should be considered as healthy, moderate, and unhealthy? And we will go from there.
Mhm.
But right now we are setting the limits in order for people to know what they are trying to achieve inside the buildings, right? Like in a hospital or in a school or in an office, what's the limit that you should achieve during 1 hour or 8 hours?
Okay, but what about the ceiling itself? Um,
To be honest with you, a ceiling limit rather than have average hours is easier
Mhm.
in order for later on to develop the index
Index
thresholds.
X.
Yes.
Mm.
It's
This is
much
why I
more.
was asking. We have to be careful in selecting the ceiling
Mhm.
because it will be part of the index. That will be
Yes.
the information that the most common people will see from the QoQS at the end. So it's
Exactly.
very important to choose the right one.
Mhm.
Is ozone also ceiling or formaldehyde? Did they decide?
In most cases, we have spoken about ceiling for ozone, formaldehyde, and carbon monoxide as well.
Mm.
But we haven't figured out the number yet, like it's pending.
Well, I think, I mean, the way I started the conversation was from the sensor capability. So I think, I know that's not based on the health, but we should guide it based on the health and then work towards sensors that can deliver that. So I think, especially with NO2, with the asthma implications, I know ozone can be an irritant as well, but I think NO2 is more famous for the asthma issue.
So to go back to the previous question, do you think we should go with 100 for 1 hour instead of 200, which is the most predominant number?
I think that sounds reasonable yeah, because that converts to like calculated around 50 ppb.
Mm-hmm.
It's 100.
Yes, I think it's divided by 2 or something.
Mhm.
We
So
can
it was
make
dividing it by molecular weight 46 and so times 24.4. Also, I'm sorry, I may need to run soon. But what the group decides, I'll go with as well.
Like if we say 50 parts per million for ozone, or yes, like around. Oh, it's way too much. That's parts per
Or
million.
per
Sorry.
billion. Yeah.
Yes. So, but yeah, it's around 50
Mhm.
and 100 micrograms.
Okay. Well, that happens to be what we can deliver, what we expect to. So that, from our point of view, I think we could work towards that.
Perfect. Any last comments? You?
Yeah, because 200 may be good for spikes, but gives the false idea that 200 is safe. So probably 100 is the right number.
Perfect. All right then. Once more, I would like to thank you for taking the time to join this meeting, and I hope I will see you in the next one. I don't know if someone is interested about Radon. It's happening in 10 minutes. Thank you.
Oh, thank you for organizing. And yeah, definitely these working groups are great. I'll try to attend the other ones as well when they come up, if we have more of these.
And tomorrow we have ventilation and filtration. Again, this is those two working groups are more of a holistic approach of indoor air quality, as ventilation and filtration are the means that we are going to use in order to, remove the pollutants from the indoor space. So we would like to learn from the experts, and hopefully many will join a little bit more about the right directions. Thank you again. Have a great day.
Thank you.
Thank you.
Thank
Thanks,
you.
everyone.
Bye.